Hi, everyone. This is Sebastian Traeger, Managing Director of Reliability Center, and welcome back to another episode of Reliability 4.0. As always, we're on a mission to help make the world a more reliable place. And today we are thrilled to be joined by Steve Heavyside. He hails from Pueblo, Colorado, and he's going to be joining us to talk about his work as Director of Corporate Reliability. Steve, it is great to have you on the call.
Thank you, Sebastian. Pleasure to be here.
So, Steve, we're just gonna dive in and start talking a little bit. I know that you've recently left Evraz, where you served as the Director of Corporate Reliability. Why don't, rather than talking about the company, just share with us what you did in that role and what your kind of responsibilities were.
Yeah, so the steel industry as a whole is very reactive maintenance centric. It's a very much a run to failure type of environment, mainly because of the type of equipment that's being operated, the throughput and various things like this. And they're late to adopt Industry 4.0 or IoT sensors. And oftentimes they're still very, very stuck on the route-based inspections where they're just going out with a piece of paper and writing down some stuff, and maybe they see something, but then they bring that piece of paper back to a supervisor who has probably 15 different people yelling at him, and that piece of paper winds up on the desk, and next thing you know, there's a stack of paper and it's moved to the trash can, right? But that's very much the steel industry as a whole. Now modern steel mills are moving more in the progressive style of Industry 4.0, and that was the direction that I was trying to take us.
Great.
Getting back to basics when it comes to precision maintenance, getting back to the supply chain. What spare parts do we have on hand? Are you changing out a small component? Are you changing out a macro piece or a sub assembly? That way you take away the variables of field maintenance and put it more back into the shop so that you have a more controlled environment. And of course, really pushing hard on the predictive, preventative, and proactive maintenance efforts.
That's great.
That was really what I was working on.
Well, that's great. Well, I want to get to know a little bit more about what you were doing, but before that, I just two kind of things I like to ask about. What is kind of your origin story, or how did you get into the kind of reliability world in the first place? How did you become a reliability engineer?
So for me, it began way back 33 years ago when I entered the U.S. Navy. Came in as a machinist mate, and at the time, what was intriguing to me is that these ships are going around the world with 100% confidence, 100% reliability, and they're being operated by people that are 18 to 30 years old. These people came out of high school and they are able to fly jets and move ships and fire missiles and do whatever, and they can do it with confidence every time. And the when you start to really dig into that, it comes back to how you train, precision, and how you maintain, which is documented procedures that work well. Now, do they have failures? Absolutely. But that was always what intrigued me. Then I started building steel mills. I came out of the U.S. Navy and started building steel mills with companies like SDI, Nucor, ThyssenKrupp. I rebuilt mills and always looked at the maintenance programs and said, man, we just don't have any, going back to my Navy days, we just don't have any of that. So started really pushing towards that precision maintenance and more proactive, predictive maintenance effort. And that's really what inspired me.
That's awesome. That's awesome. I mean, A, thank you for serving, and B, that's very encouraging to hear that our Navy takes that seriously and has kind of programs in place. I mean, that's just really encouraging because, to your point, it's got to work when it's got to work, right? Like it's just there's no ifs, ands. Well, before we dive back into your kind of previous role and how you think about reliability, one thing you like to do outside of work. Just give us a little bit about who Steve is outside of the workplace.
Two things. I remember Bikers Against Child Abuse. We work with abused children to empower them to not be afraid of the world in which they live. I've been doing that for about 10 years now. And then the other thing is my wife and I have a model railroad business. And I've been model railroading for about 50 years. The thing of it is it's really a gateway to working with your hands. It brings in artistic, mechanical, mechatronics, electronics, art, you name it. It has everything there to really begin the journey into STEM. And so part of our efforts, we're developing a 501c3 to engage kids on the spectrum as well as young children into model railroading, to enter them into the path of skilled trades.
I love it. That's great. That's such a cool hobby. And so just a quick follow-up. I know I'm just interested. So are you selling sets? Are you putting them on in large displays? Is it all the above? What exactly does that look like?
All the above. We actually just had one of our layouts showcased at a Smithsonian event in Trinidad, Colorado, along with some other stuff. But we have everything from components all the way up to big sets, little Z scale trains, all the way up through garden scale trains, which are 120.3, live steam, electric, you name it. We have it all.
Awesome. I love it. Well, let's dive back into your work. As you think about, kind of your role in reliability engineering, what are some of the core goals that you have, KPIs, or if that's what you call them, or metrics? What are you kind of solving for in the work?
So really, when you're looking at the steel mill, you really have to understand what delays are affecting you daily. And is it a great big delay, or is it all these little death by thousand cuts? So we did a lot of work around Paretoing our delays to understand what your top 3 to 5 delays are every day. And then our reliability engineers and reliability managers will go to work on problem solving that, whether it be a simple back of the napkin 5Y or a fishbone, or did we need to get into a root cause failure analysis? And we really preached that we don't want root cause failure analysis done in a vacuum. In other words, we don't want just the reliability engineer to do it. We want the reliability engineer to get the people who are actually involved in that root cause failure analysis. You don't want Steve Heavyside there. You want the guy who's operating the equipment and the guy who's maintaining the equipment. I mean, don't get me wrong, I will be there, but we want to know first from the front line what happened. When we start really digging into that, the common themes come up to be training, or precision maintenance, or spare parts. It was those 3 things. From the root cause failure analysis, we would set a PM, whether it be predictive, proactive, preventative. Maybe we need to do some redesign, but a lot of it came back to training. And really that's the direction that we were taking it.
And just to be clear, specifically on the training, you mean the person maintaining the equipment not being trained in how to do it, or a different type of training?
That, as well as maybe they don't know how to properly operate it because of turnover from the operation side. A lot of people look at reliability as a subset of maintenance, but really it's the umbrella for the entire organization to look holistically across your operation to see where the gaps are. And, if you've got gaps in operational training, operational performance, quality, maintenance, engineering, we're looking holistically at that, not poking people, not pointing a finger at them, but just saying, hey, answer the questions, answer them truthfully, and let's work on it, whatever it is. And, let's be honest, when you're breaking equipment, a lot of times it's because we decided to operate it beyond its capability, or we didn't know how to do so. One of my favorite analogies is you've got the race car driver going around the track. He's supposed to be turning left, and for some reason he decided to turn right, puts it into the wall. Well, is that the fault of the maintenance department? No. Is it necessarily the fault of the operator? No. Maybe something distracted you. Maybe something, it doesn't matter. Just tell us what happened, and let's go solve that problem. It's
good.
The other piece of that is as you know, as you dig in deeper into reliability, then you say, okay, well, how can we predict that the operator is going to turn right when he should have turned left? Or can we prevent the turning of right? Maybe not so aggressive, but maybe can we limit how far he can turn? That way we try to keep the car off the wall. And, these are the types of things that my team really dug into quite heavily.
That's good.
And then the other piece of it is with a lot of the steel mills that I formerly worked at, age of the equipment. We literally had an operating Smithsonian exhibit. The rail mill in Pueblo is early 1900s, late 1800s equipment. And so how do you adapt IIoT to a piece of equipment that literally is, hammer fit, right? But we were doing it, and it's not just there; it's across the board. And sometimes then you have to look at what new technology's out there. I know we blurred my screen out, but right up there behind my head is a HoloLens, and we were putting we were starting to look at putting wearable computers on people so that their hands are free, more safe, but they had real-time access to information about that piece of equipment that was built 100 years before they were born.
Huh.
And so they didn't have to guess. They could get real-time information.
Okay, fascinating. You mentioned something interesting, well, a number of things, but one thing I want to drill down on is just talking about Pareto. How valuable is that, and how frequently would you do that? Would you do that once a month, let's pull a Pareto, or is it more like every 6 months, every 12? What's the right amount of time to do that?
We were pulling Paretos weekly. So we would Pareto our delays weekly, and we would look at them. And like I said, that's why we only took the top 3 to 5. And we broke it down by operations, maintenance, and electrical. Or I'm sorry, operations, mechanical, electrical, and at one of my previous facilities, we added automation in there as well. But we Paretoed in those categories, and then we broke those subsets out so that we could see, A, is there any overlap? But B, what can we affect today? And you'd be surprised by how often that death by 1,000 cuts comes up into your top 3 delays, and maybe you're just going to solve a 3-minute delay. It could be a simple, literally a simple 5Y that solves that, and next thing you know, that death by 1,000 cut is gone. And you're talking more about the big thing. Everybody remembers the big thing, but they don't ever remember the small thing.
Yeah.
So you solve the small and get rid of it.
So going back to this, like once a week, why, like if you're doing it that frequently and those problems are getting solved, is there a way to connect ROI to solving those problems? Were you able to do that to say, here's if we did more of them, or as we do them, how do you kind of show that there's value in that?
Yeah. So obviously, you're not necessarily going to do it for everything that floats to the top of the list, but I'll give you a for instance. One of the mills within the organization I was previously with, we struggled with our roll line rolls. We routinely failed them at a cost of $45,000 per coupling, $1,000 per bearing, 2 bearings. But the delay side was huge. We would lose, anywhere from 6 to 8 hours of delay every day or every other day. So when we started digging into the Pareto, when we Paretoed it and started digging into the root cause, we found that training, tools, alignment, these types of things were what was causing this. So we put a value on, okay, how much is it going to cost us to train our personnel? How much? I spent $200,000 in torquing equipment. We bought a laser alignment. We trained everybody on laser alignment, just various things. And next thing you know, that 8-hour delay every other day is gone. So
that's incredible.
The cost, and we're talking like a reduction of about 3% of overall delay rate, 3 to 4% of overall delay rate in a 1,000,000-ton facility.
Yeah.
So the ROI was immediate and impactful to the business. And the trickle out effect was your maintenance team is not just butt whipped when they walk back to the locker room at the end of the day because they've been wrestling with this, 5-ton, 10-ton roll, but also the effect on quality, because you're not scratching your plate. You're just the trickle out became huge.
Yeah.
And so the ROI was immediately and impactful. Now,
Great.
is that how every delay is going to be? No. Or every Pareto? No, that's not how it's always going to be. But you can get some big wins. And then the big thing about that is you celebrate that wins with the frontline employee. They drove it. They recognized it. We identified it, but they drove it. They recognized it. They said, these are the things that we need to be successful. And when you give them that empowerment, it makes it very easy to go tackle the next piece.
Yeah. Absolutely. Well, and just even thinking about, I like how you talked about it for the folks on the front line, but I was even thinking about it about management and making a business case to get more resources to make things better. Obviously, if you're showing a systematic process where things are getting improved and ROI from them, that's a great process. Who doesn't want to keep investing in that?
Yeah, and the Evraz does a lot around that employee engagement piece. I was really proud of a lot of the things that we accomplished through that. And that's exactly what it was. The new leadership team that came in a few years ago, they really worked hard on the empowerment and engagement of the front line. And it was truly about driving these types of changes, building the culture from the floor up. And reliability was part of it. Now, the problem is that when you have an older facility or older facilities with well-established maintenance teams that are deep in their careers, change becomes hard. And when you're talking about reliability, granted, reliability has been around for decades upon decades upon decades, but when your number one team puts on their Superman cape and goes out there and solves the fire, don't talk to him about reliability. He wants to go out there and solve the fire because that's what makes him number one, right?
Yeah.
And you try to really influence them by saying, hey, look, let's work smarter, not harder. I want you to put on a different Superman cape, solve the problem before it is a problem.
Good.
So culture change takes time. That part of it takes a lot of time.
Well, there is a lot more we can talk about, but we have reached kind of that point where we're going to wrap up. But I always like to ask folks kind of the one piece of advice from expertise or experience, and you've already given, I think, so many just encouraging nuggets. But is there anything else you would say? And I like to kind of channel it to maybe the reliability engineer who's starting out, who's just getting going. What's the kind of word of advice or something you might want to encourage them by?
Really, I think for the future, we really need to learn to adopt technology early. There's so much that we can do now with wearable computers, IoT sensors. Many of these engineers have been playing in their bedroom or schools or whatever with mechatronics, and they already understand the fundamentals of many little things. But engaging them through technology, driving them into industry is paramount for the future. And then us older salts, us guys that are at the end of our career, really have to take a little faith that these kids know what they're talking about. And maybe we teach them what we know and learn from them what they know. That's really the big thing that we're going to have to harness coming forward.
Yeah, I mean, I'm a big baseball fan. I often like to talk about how sabermetrics, which is kind of like using data to predict what baseball players are going to do. There's a big wave of that. And, kind of the quote, older scouts were at first a little nervous or the opposite, just dismissive. And I think the reality is actually both approaches are really helpful and they're even more powerful when they're working together. And that's, I think, what you're saying about the world of reliability.
100%, sir.
Well, thank you so much. This has been Steve Heavyside. Again, he's just been awesome to listen to, coming at us from Pueblo, Colorado. Thank you so much to all those listeners out there. As we've said before, we're really about helping reliability engineers and really anybody else take steps to, using technology to be more successful in the work that they do. And I hope this conversation was helpful in that. Our company Reliability helps out with RCA, RCFA. So if you need training or resource materials, please check us out. We also have a software application called Easy RCA. So if that can be useful, let us know. We're happy to help in any way that we can. Well, that's all that we've got for today. Thank you all. And let's go forth and make the world a more reliable place. We'll see you in the next episode. Thanks.